Alright, we're go to math, working some calculus. We're in the section continuity and one-sided limits, and that right there is where we're at. Whatever you want to call that, button 4, problem set 4. We have a piecewise function that's not written in the traditional manner, but that's okay. I'll get that straightened out here in a minute. We got the limit as x approaches 9 from the left-hand side of f of x. So let's move over to the board. Let's clear out last night's work, or yesterday's work, or was that 2 minutes ago? And we'll go ahead and use blue. So we got f of x is equal to, this is the traditional way, we got a big curly bracket there, or curly brace, x, we have the domain as x is everything but 9, okay? And this one's going to be 3, f of x equal to 3, and its domain is going to be only 9. We're asked to find the limit as x approaches 9 with a minus up here. That means we're coming in from the left of f of x. And yeah, it is f of x. Okay. Let me sketch out what this graph, get a good idea of what the graph looks like. First, let's graph this function f of x is equal to x. And actually, first thing I'm going to do is let's label where 9 is right there on the x-axis. So we got a line going at about a 45-degree angle there, has a slope of 1, and a missing point right here at 9 because it says we cannot use 9 in the domain. All right, and goes on that way, goes on forever back in that direction. Alright, this one here is a constant, f of x is equal to 3, so that would be, actually, I'm going to label about where this hole is located here on the y. How's that? 3, we'll say that's somewhere right in here. But we can't use anything except 9, so that means that right here, we'll say 3 is right here. We'll put a solid dot, and we're just going to say this is 3. Of course, this is not the scale, but alright. So this is what we got. Now we're coming in from the left-hand side. Alright, so as we get closer and closer to 9, you can see that our y value is getting closer and closer to this missing point here. This is coming in from the left, is getting closer and closer to 9. Okay, it's getting closer and closer to 9. So we can easily see that, right? Easily see that. We'll put 9 right here. Now, if we were to ask this question, because we're going to answer something about continuity here in just a second. What is this? Well, we're coming in from the right-hand side, right? Coming in from the right-hand side, and as you can see, for each x value, we get a y value on the line up here. Right, and as we get closer and closer to 9, our y value is getting closer and closer to this missing point, which is 9. So now, since coming in from the left is equal to 9 and coming in from the right is equal to 9, therefore we could say that the limit as x approaches 9 of f of x is equal to what? Equal to 9. Right? Okay, now let's talk about continuity. Where is this graph not continuous? Well, I'm going to say that it's not continuous when x equals 9. There are 3 things that we must check. First off, we must check f of 9. Well, when we plug in f of 9, we get 3. Okay, this is the only defined point right here, which is going to be 3. Second thing we must check, both these numbers